Good morning. Today we are making the video for packet number 9. It is due next week, Friday. On our first page, it says Bob Superball bounces exactly half the height from which it is dropped. He drops the ball from the top of the building that is 64 meters tall. How high will the ball bounce on its 8th bounce? Spoiler, it is not 64 divided by 8. That is just way too easy peasy. We have to do some math here, okay? So, let's draw the picture so we can visualize what it is that's happening. He drops the ball down 64 meters. It bounces up half its height. So I have to say, well, what's half of 64? It's 32 meters. And then it's going to bounce again. That's our first bounce. It bounces 32 meters. Then it's going to bounce a second bounce. So again, half of that first bounce it had. So half of 32. So we're going to keep finding the halves all the way down to the 8th bounce. And I am going to tell you, it gets to be, think about a ball bouncing. When it gets to the end of its bouncing, it's really teeny tiny bounces. So you're gonna end up with a teeny tiny number, and that's okay. Right? As that ball bounces, it gets smaller and smaller and smaller. It will be a little itty bitty bounce. So keep dividing down till you get to that 8th bounce. Our next page. A florist is making identical bouquets from 36 tulips, 27 roses, and 18 lilies. No flowers should be left over, so we're dividing them up evenly. What is the greatest number of identical bouquets that the florist can make? So that's our first question. You need to find that greatest common factor of all 3 of those numbers. It has been a while since we did the GCF, the greatest common factor. So one way we found that, remember, was we did our table method. We had 36 tulips, 27 roses, and 18 lilies. Remember, you look at those 3 numbers and say, what factor can I divide out of those numbers? You put that over here, whatever that number is, you divide and put what is left when you divide that number out. When you get these 3 numbers, if you can divide another factor out, you divide that factor out, and then you put what is left. If you have 2 numbers that you divided out, you multiply them together to get your greatest common factor. That's how many bouquets there will be. Then we have to go back and say, okay, I have tulips, roses, and lilies. How many are going to be in each of those bouquets? So you're going to have to say, what's its factor, buddy? If I have 36 tulips, and if I divided out 12 to make 12 bouquets, what would 36 divided by 12 be? That would be 3. So there would be 3 tulips in each bouquet. Spoiler, that's not the answer. I'm not giving you answers. I'm just explaining. You figure out how many identical bouquets there are, then find its factor, buddy, to know how many tulips, how many roses, how many lilies. Find the factor buddies for it. Our next page is the 5-card challenge. We know how to do these pages. So work through your equations. Remember, you can't just flip a number and call it a new equation. If it's the same operations happening, -4 is -4. Doesn't matter where it falls in there. If it's the same operations, it's the same equation. You have to do something new. Did you have a question, Alex? Then we have our pattern page. I know when I copied it out, that purple is super dark, and it's hard to see how many squares there are for our pattern. So I'm gonna walk us through. We only have to do the total blocks. I'm not worried about the purple and the green. So I'm just gonna count them. I've got 1, 2, 3 across, 1, 2, 3 going down. So 3 times 3 is 3 squared. That is 9. This one I have 1, 2, 3, 4, 5, 6 across. 1, 2, 3, 4, 5, 6 going down. 6 times 6 is 36. This one I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do we call these beautiful numbers? Michael?
Perfect square.
Perfect squares. All right, when you've got those squares and multiplying the length times the width, perfect squares, oh, we see perfect squares all the time in our patterns. 9 times 9 is 81. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squared. What is 12 squared? Who can tell me? Jackson. 144. Can we see a pattern with our perfect squares?
Yes.
Follow that pattern down to figure out your missing numbers. Always look for those patterns. Next page. Our shaded figure. The area of the figure is the full figure. To find that, it is a square. So the area of a square is length times width. Figure out the area of that full square. Then it says find the shaded area. Well, in order to find the shaded, we take the full minus the white, and we're left with the shaded. That white is a circle. The area of a circle is pi times r squared. Remember, r is the radius. It goes from the middle to the outside. If we know from the end to the end, that is the diameter, we want half of that to find the radius. So you're going to find the area of the white circle, subtract it from the full area, and you're left with your shaded area. Next page. Oh, whoops, this page got flipped upside down. Okay, this one says draw a net of the figure and label its sides. So it is a rectangular prism. Remember how to do that rectangular prism. You start with the bottom shape, and then you have to do each of those 4 smaller sides. Don't forget the top. You have to figure out those labels. Where are the 9s, the 5s, and the x's? You don't have to solve for x. I've had a few friends who looked at the volume for pre-algebra and they figured out what that number would be for the x. You can just label it with an x. Okay. So we're not working through with the volume. We are just drawing the net and labeling every single side, even the inside sides. Okay, we've done this before. You know how to do this. If you need help, make sure you come and ask me. But we do need a number on every line, and you need to visualize if we fold it back up, that top and the bottom should be the exact same size. If we think about our Kleenex box, if we cut it open and laid it flat, the top of the Kleenex box lines up perfectly with the bottom of the Kleenex box. On this page, it is just like the one in our last packet, except we have different volumes. The formulas stay the same, okay? It's always length times width times height for a rectangular prism. He is giving us the width and the height, so you can do opposite operations to find that missing length. Okay, so if it's length times width times height equals your volume of 60, do opposite operations, divide it out, and find what's missing. For our cube, length times width times height, but remember, you have to have the same number because it's a cube, it's a square. They all have to be the exact same number that you multiply together to get to 27. That does not mean it's 27 divided by 3. Okay? You have, that would be 9. 9 times 9 times 9 is way bigger than 27. So you have to say, what number can I multiply by itself 3 times to get to 27? I will write out our other formulas in case you want to challenge yourself to find some other ones. So the triangular prism is the length times the width times the height, and we divide it by 2. For a pyramid, it is a length times the width times the height divided by 3. For a cylinder, it is pi times r squared times the height. A cone is pi times r squared, and our height is divided by 3. And for our sphere, it is 4/3 pi times r cubed. So you don't have to do more than 2, but you certainly can challenge yourself to which ones you want to do and how many of them you want to do. I've had some friends do all of them, just for the challenge. As long as you get 2 correct, you pass the page. Okay. Doing the other ones just gives us extra work, extra time practicing, working out those formulas. It's going to help you on that math test that we're taking next month. Right? It just gives you some extra practice. You have to do 2, you can do more. As long as you get 2 correct, you pass the page. And our last page, we have tally marks showing the number of customers on each day of the week. You need to make a graph, make a bar graph. Make sure when you make that graph and you're writing in your words here and you're writing your numbers here, you give a label. I need to know what those words are. I need to know what those numbers are. So make sure you label it. And notice that it's asking some questions. How many customers come during the week? How many during the weekend? So not only do we have to have a graph that's labeled correctly, we also have to answer the questions. If you have enough room on your paper to make a graph on the paper, awesome, awesome. If you say, ooh, I want a little more space, I've got paper up front here. Grab a piece of paper, make your graph on one of my papers up front and staple it. Okay, so you don't have to squish it on, but you can. If you want to use a separate paper, you can also do that. Remember, this is due next week, Friday. If you turn it in any day before then, you will get to fix your mistakes. Ooh, it would be really nice to get 10 out of 10 on this packet. All right, that's going to help our learning, mastering all these different types of things that we're doing. It's also going to help our grade. Turn it in early. Don't just wait until Friday and turn it in and say, yeah, I have no idea. I guessed on some of these. Turn it in early so we can fix those mistakes. Learn from our mistakes. If you still have questions on any of these, make sure you come and ask me about it. Make sure you turn it in early so we can fix mistakes. If you are watching at home, I hope you are well. I hope to see you soon. Have a wonderful day.